Okay, so in the x direction, I'm going to have 120. The component of this is going to be to the right as well, so that's plus adjacent to the angle, so that's going to be 40 cos 60 degrees, and all of that together is a very nice flat round 140 newtons. In the y direction, the only vector that is acting is the vertical component of the 40 newton. So that's going to be 40 sine 60 degrees. And that is 34.6 newtons. So let me sketch these two perpendicular vectors. Okay, so this is my resultant. The horizontal vector is 140. The vertical vector is a lot smaller, so I drew it a bit shorter. It's 34.6 newtons. So the resultant is the square root of 140 squared plus 4.6 all squared. That is 144.2, but I'll just leave it as 144 since that's three significant figures, newtons. And the angle that it makes with the horizontal axis is tan inverse of opposite, so that's the vertical over the horizontal from my diagram, which works out to be 13.9 degrees. Okay, so moving on to number 2. Okay, so in the x direction, now I realize that this one is acting to the left, so it's actually going to be minus 35, and the component of this vector is also going to be acting to the left, so the horizontal component will also be negative when I'm factoring direction, when I'm finding the total horizontal component. So let's see. That's going to be 35, well, minus 35 plus, right, minus 47. Now the horizontal component of the 47 is opposite to the angle, so I'm going to use sine. That gives me, so this worked out to be 36, so it's minus 35 plus minus 36, which altogether is minus 71 newtons. Okay, in the y direction, the vertical component is acting upwards, so that is going to be positive, and the only vector acting in the y direction or vertically is the vertical component of the 47, and the vertical component is adjacent to the angle, so I'll use cos. So that's going to be 47 cos 50, which is 30.2 newtons. Right, so this is my horizontal vector, this is my vertical vector, so let's sketch it. Now I realize that my horizontal vector is acting to the left, so I'm going to sketch it in that way, but the vertical component is positive, so my new sketch will look like this. Draw this line a bit longer, and I'll draw this one like this, right? Okay, so this is 71, and this is 30.2, right? So in case some of you are like, well, where's the minus sign? Again, I didn't draw it because the diagram is showing me the direction. So you can write the minus 71 if you want. I'm letting my diagram speak for the direction. Okay, so what's the resultant? Well, nothing has changed. It's still the square root of, it's still equal to the square root of the sum of the perpendicular sides, right? So minus 71 squared plus 30.2 squared, and what's the square root of all of that? It's 77.2, so this is 77.2 here, and alpha, which I'm still going to use alpha as the angle between the resultant and the horizontal axis, is going to be tan inverse of opposite over adjacent, so my vertical over my horizontal, minus 71, which is going to be, well, actually, you know what, I just want the size of the angle. I'm letting my diagram speak for direction, so I'm just going to use the magnitude of the vector, which is 71, and tan inverse of 30.2 all over 71 gives me an angle of 23.0 degrees. So my resultant force is 77.2 newtons acting at 23 degrees from the horizontal component. So moving on to questions 3 and 4. Okay, so here for question 3, in the x direction, I have the both components of these vectors acting to the right, so that is going to be 10 cos 30, right, the horizontal component of this guy, plus 8 cos 11, that gives me 16.9. In the y direction, this component is going to be positive, but the vertical component of this vector is going to be negative because it's below the horizontal axis. So that's why I have 10 sine 30 minus 8 sine 11, right? So it's vector addition. I've written it in this format because it's this component plus this component, but this component is negative because it's acting downward, right? So that gives us the 3.47, so it's still like a positive value. So at the end of the day, the net vector is positive, so that means my diagram will look like this, right, acting up and acting to the right, and my resultant, right, the root of the sum of the squares of the perpendicular sides, I got 16.9 newtons. The angle that I've chosen, we can see from the diagram, I'm still sticking with the angle between the resultant and the horizontal axis. So that's tan inverse of the vertical over the horizontal, because opposite over adjacent for tan, and that worked out to be 11.9 degrees. So for number 4, right, here we have number 4. And let's go through it. Well, okay, 3 vectors here. So in the x direction, the horizontal component of the 32 newton is going to be positive because it's acting to the right. The horizontal component of the 40 newton is also going to be positive because it's acting to the right. But the 18 newton, which is horizontal, acting in the horizontal axis, is going to be negative. So that is 32 cos 25 plus 40 cos 10, right? these are the horizontal components of these two, but it's going to be minus 18. So when you work all of that out, I got 40.4 newtons, right? So the horizontal vector is 50.4. And in the y direction, well, this is not going to have any sort of contribution to anything in the y direction. So the vectors acting in the y direction are just the vertical components due to these two. So this component is going to be positive, so that's 32 sine 25, but it's going to be minus 40 sine 10, and that gave me 6.58, so I filled it in there, and my resultant was 50.8, and the angle was 7.44.